The James Webb Telescope has been focusing on the deepest mysteries of the universe for more than 2 years, and it has already discovered a wide range of structures that, in our opinion, shouldn't exist at all in this form, where our current models have reached their limits. Is this evidence of the existence of another universe? The British physicist and Nobel Prize winner Roger Penrose is the most well-known proponent of a theory that eventually comes into play. According to Penrose, the Big Bang was not the beginning of everything, but rather the explosive transition between two cosmic chapters. In fact, Penrose is certain that the universe has always been subject to a fixed cycle of destruction and rebirth, and astonishingly, the most recent discoveries even suggest that he is correct. But what about the enigmatic Hawking points, which, in Penrose's opinion, represent the remains of a previous cosmos? Infinity is limited, well, at least for us, although quite a few experts suspect that the universe is infinite. From our earthly point of view, we are only able to see an infinitesimally small fraction of the whole. Our spherical field of vision is appropriately referred to as the observable universe, and it encompasses the area from which information could have reached the Earth since the Big Bang. Given that the cosmic birth took place 13.8 billion years ago, one might think that the distance to our natural line of sight, the so-called event horizon, is also 13.8 billion light-years. But that's not true. After all, the cosmos, space, has been continuously expanding since the beginning of time, which means that distances already covered have been lengthened retrospectively. The distance to the observation horizon is ultimately estimated at 46.3 billion light-years. What is exciting here is the fact that every point in the universe has its own observable universe. In other words, if there is a civilization billions of light-years away out there, it can see a part of space that will forever remain the great unknown to us. As a result of these cosmic blinkers, experts can only speculate about what lies dormant outside our field of vision. While many researchers believe that the structures there correspond to those in the local universe, others estimate that the invisible depths of space are much more bizarre than we can even imagine. However, the black hole that the James Webb Telescope added to the star charts a few weeks ago was also much more bizarre than we could have ever imagined. Christened with the scientific name L1526, the gravity monster had already existed for 1.5 billion years after the Big Bang. Despite this, it apparently devoured matter 40 times faster than is theoretically possible. But let's be clear. This mysterious Webb discovery by no means marks an astronomical exception, but rather corresponds to the new, confusing pattern. We now know of a whole series of black holes that simply appear far too massive for their early formation. These include the quasar, an active galactic nucleus called J120+0641, which dates from the cosmic twilight era but already weighs over 1 billion solar masses. To the researchers' dismay, however, a closer examination with Webb's mid-infrared instrument MIRI failed to reveal any extraordinary feeding mechanism. It turns out that we simply don't know how a supermassive black hole could have been fully mature when the cosmos was only 5% of its present age. Since our current models can no longer explain the cosmic premature babies of the observable universe, new approaches must be taken into consideration. The fact that these sometimes have the potential to revolutionize our understanding of the universe is demonstrated by Sophie Kidman's remarks. Asked whether the surprisingly massive black holes could have formed from structures that existed even before the Big Bang, the astrophysicist from the University of Cambridge replied, "The exciting thing about this question is that nothing is ruled out. Some people say that the massive black holes we have now found in the early universe must have been formed by a direct collapse. There are several publications that suggest the observations prove this. If black holes grow efficiently, they have just enough time to develop from a very light seed. Although Kidman emphasizes that this model is just one of many explanations, it does come up with a groundbreaking premise, namely, that there actually was something before the Big Bang and thus before our universe.